Today we're going to learn about speed word problems. Problem 1. Now, let's say we have a problem like car A and car B are traveling outside Houston in opposite directions. Car A is 50 miles from Houston and is traveling at the speed of 45 miles per hour towards Houston. Car B is 19 miles from Houston and is moving away from the city at 35 miles per hour. A. Write an equation to describe car A's situation. B. Write an equation to describe car B's situation. And C. In how much time will car A and car B pass each other? Now, let's first start by solving problem A. Problem A is write an equation to describe car A's situation. Let's first draw car A's situation. So, this is the road that car A is on, and here is Houston. H for Houston. Here is car A. Let's write this in blue. And here is car A. Car A is 50 miles from Houston. So let's write that down. The distance from this spot on the road to this spot on the road is 50 miles. Now car A is going towards Houston. So car A is going towards Houston at the speed of 45 miles per hour. So at the speed of 45 mph, miles per hour. Now before we write an equation to show car A's situation, let's first get this formula drilled in our minds. So the speed, S for speed, is equal to D for distance over time, T for time. So this means that 45 miles per hour, which is the speed of car A, so 45 is equal to D, let's write this D properly, is equal to D over T. So, this means that the distance traveled and the amount of time given, so D, which is the distance traveled and the amount of time given, is equal to 45 times T, which is the amount of time given. So this means that D is equal to 45 times T, which is equal to 45 T. Now let's write an equation to show car A's situation. So, car A is 50 miles away from Houston. So let's first write 50. So car A is 50 miles away from Houston. So 50, and is going towards the city of Houston. So, in the amount of time given, car A will reduce the itself and Houston. So this means that we have to do 50 minus, because we are reducing the distance, so 50 minus 45t. 45t. So, the equation to show car A's situation is 50 minus 45t. Now let's solve problem B. Problem B is write an equation to describe car B's situation. Let's draw a dividing line before we start this problem. Now let's draw another number line, or another road, which car B is on. So, this is the road. Let's make this road a bit longer. This is the road, and here is Houston. H for Houston. Car B is 19 miles away from Houston. 19 miles away from Houston, and is going away from the city. So this means that car B is approximately, let's say 19 miles is right here. So car B is 19 miles away from Houston. Car B is 19 miles away from Houston. So, the distance from here to here is 19 miles. Is 19 miles. Car B is going away from Houston. So this means that car B is going this way at 35 miles per hour. So 35 mph, miles per hour. Once again, before we start solving this, or before we start writing this equation, let's first get the same formula drilled in our mind again. It is speed, S for speed, is equal to distance, D for distance, over time, T for time. So this means that 35, which is 35 miles per hour, which is the speed of car B, so 35 is equal to D over T. So, this means that D, the distance traveled in the amount of time given, is equal to 35 times T. And T is the amount of time given. This is equal to 35t. Now let's write the equation for problem B. Car B, well, let's first. So car B is 19 miles away from Houston. 19 miles away from Houston. So let's write 19. And is increasing the distance between itself and Houston because it is going away from Houston. So we have to add, because when we add, we are making the distance longer. So 19 plus 35t, which which is the amount of distance he is traveling after the 19 miles in the amount of time he is given. So 19 plus 35t. So the answer to problem B is write an equation to describe car B's situation is 19 plus 35t. Now, before we solve problem C, let's draw another divided line. Now, problem C is in how much time will car A and car B pass each other? Now, let's first draw the road on which both car A and car B are on. So, this is the road. This is the road that both car A and car B are on. And here is Houston, H for Houston. Car A is right here. So, this is car A, and it is traveling towards Houston at 45 miles per hour. Now, this means that the distance from here to here is 50 miles. So from here to here is 50 miles. Now car B is 19 miles from Houston. Car B is here. This is 19 miles away from Houston. Car B. And car B is traveling away from Houston and in the opposite direction as car A. So that means that car B must be traveling this way, towards car A. So car B must be traveling this way and is traveling at 35 miles per hour. So 35 mph, miles per hour. Now, let's write this here that the distance from here to here is 19 miles. Now, let's find the distance between car A and car B. The distance between car A and car B is 50 minus 19. This is equal to the distance, D for distance, is equal to 50 minus 19, which is equal to 31 miles. Now, since car A and car B are traveling in opposite directions, then together they travel 35 plus 45, which is equal to 80 miles per hour. So let's write that down. The total speed, TS, let's write this smaller. Total speed, TS, is equal to 35 plus 45, which is equal to, let's write this down, which is equal to 80 miles per hour, mph. Now, let's find the speed of the total speed for 1 minute. So, this is 80 So let's write miles up here and minutes up here. So how many minutes does it take for them to travel 31 miles? Instead of putting a question mark here, like we normally would, let's put a T for time. So we have to now cross multiply. So we do T times 4/3 and 1 times 31. We get 4/3 T is equal to 31 times 1 is 31. Now, we have to get T on one side. So on both the sides of the equation, let's write this equation a little bit more to the right. 4/3 T is equal to 31 times 1, which is equal to 31. So, we need to get T on one side of this equation. So, let's first get rid of the 3 on this side by timesing both sides or multiplying both sides by 3. So, multiplying by 3 on this side and multiplying by 3 on this side. Now we have to get rid of the 4. So we divide 4 on both sides. So divide by 4 and divide by 4. So the 3 cancels out with the 3 and the 4 cancels out with the 4. And we get that T is equal to 31 times 3 over 4, which is equal to 31 times 3 is 93 over 4, which is equal to 23 and 1/4. So it takes them 23 minutes and 23 1/4 minutes to pass each other. Let's write that down here. The answer to question C is is 23 1/4 minutes. 23 1/4 minutes. MIN. Today we learned about speed word problems. Problem 1. Thank you for watching this video.